Hey Munro fans, Mike Oakes here at the ACT Expo in Anaheim, California. For those of you not familiar with me, I'm Munro's lead for business development. And here today I have Kevin Matthews with us that asked him to come out early while you can hear in the background we're still setting up. We asked Kevin to share with us the first student, is that right?
Yep.
I got it right? Their model for their business, very interesting. But I want to have Kevin introduce himself first. So Kevin.
Well, thanks Mike for having us here. We appreciate being a part of this and reaching your audience. Everybody needs to learn,
Yes.
Really important to do. So I'm Kevin Matthews, I'm head of electrification for First Student. First Student is North America's largest operator of school buses for school districts. So we operate in 44 states, 6 provinces of Canada, and operate 46,000 of these beauties that you see behind us. To put it in perspective, the Sunday after Thanksgiving, the U.S. airline industry set a record. They moved 3 million passengers that day. So that's everybody from American, Delta, Southwest, Breeze, all the way down. Record-setting day for them. Monday morning, First Student and First Student alone took 2.7 million kids to school.
That's huge.
And that afternoon took 2.7 million home, and we did it Tuesday, Wednesday, Thursday, and Friday. Do it 180
the rest of the week.
Do it 180 days out of the year.
Yeah.
So a very large operation that the biggest people transportation company in North America.
Yeah. And that's what I was impressed with a little bit of time we've been talking this morning, is that just a complete solution provider.
Right.
You're agnostic to the bus providers, right? Boeing, Airbus. And agnostic to the rest of the solution that you work with these districts to deliver. They're under a lot of cost pressure.
Yes.
Right, that you're helping delivering them a solution that they're probably not equipped to venture into on their own.
Yeah. So electrification is the biggest change the school bus industry has ever seen.
Yeah.
They've been making school buses for 100 years now. Bluebird's celebrating its 100th anniversary next year. And some people were making school buses before then. So moving to electrification is a massive change.
Yeah.
So you've had school districts, transportation managers been operating diesel buses their entire career.
Yeah.
And so now this massive change comes into electrification, which in some ways makes it easier. A lot less moving parts, a lot less maintenance to the bus, but now you're adding charging infrastructure.
Yeah.
And so that is a new element that comes in there. And then, you're dealing with people with concerns about range anxiety.
Yes.
And so they're like, do we do this? Can we do this? Can't we do this? And what's interesting is the school bus is uniquely suited for electrification. Mm-hmm. So this vehicle typically goes across US 40 miles in the morning, 40 miles in the afternoon.
Yeah.
That's the typical operating. So electrification, it's ideally suited to do.
Right.
And that's why we're really excited about the change that's going on in the industry. Not only what it means for maintenance type of deals, but we're doing this for student safety. Is first and foremost of everything we do every single day. We have a societal trust to take care of the nation's children.
Yeah.
And so we're doing this for safety reasons. We began to look at what the safety issues were going to be in the future and looking at the emissions from the buses and the exposure to children in our cabin, our drivers, and then recognizing the communities we operate into, what we're doing. And when you operate 46,000 vehicles a day, you're having a big impact.
Yeah.
And so moving to zero emissions we decided to go that way for safety reasons, but it's also going to have economic and operational benefits for us as well.
Yeah. Yeah. So knowing that our subscribers love to hear some technical details,
Sure.
Could we walk around the bus a little bit
We'll do this one.
Give me some highlights?
Yeah, so this is what's known, this bus is from International Motors, built in Tulsa, Oklahoma. This is what we call a Type C school bus. So most people, this is the most common type of bus you'll see, and about 70% of buses look like this, meaning you have the hood up front, the engine cowling. They're all electric. So they went in and started producing all electric units 3 years ago. And we've been purchasing them from the company as well as from other operators, Bluebird and Thomas, which is a division of Daimler built in High Point, North Carolina. And so every electric school bus looks almost identical to what you see today. And that's basically what they've done, is they take their standard school bus and put in a new drivetrain. And school bus industry's actually been doing that for a while because they produce diesel, gasoline, CNG,
Yeah.
and propane school buses. So they all, you know, they've been used to adding it. And if we had time, we could crawl up underneath here, and you can see there's a lot of room
Yeah.
underneath the school bus.
Right, and between the rails.
Exactly.
Yeah.
So where the diesel tanks used to sit, pull those out, you got room for the battery packs.
Yeah.
You had now all this space where the engine used to be, that now you put all your power electronics up in there. And so then you can put in the motor basically in this part of the cabin area of the bus. So it's a pretty, I'm not going to say it's easy,
Yeah.
but they've been able to really work within their existing footprint to make the system work.
Yes. Yeah.
So this is the typical Type C school bus that you'll see. The Type D, just if people want to know, that's the one that's got the flat front on it.
Yeah.
So they also make them in electric. And then the Type A school bus is the smaller 26 passenger or less school bus you see running around. Those come in electric as well.
Looks like the front of a van.
Exactly. They're typically it's a lot of people
Ford.
call them the cutaway.
Oh,
So
yeah.
the chassis made by GM, Ford, and then
Yeah.
you put a school bus body on them. And now they come in electric as well. They're made by a few different companies as well as that.
So some technical details.
Yep.
Range.
So the range on this bus, this is IC's largest battery pack. It's a 315 kilowatt hour battery pack that comes in this one. They also make one in the 210 kilowatt hour battery pack. So that drives range as this. Typically out of a 315 kilowatt hour battery pack, we'll estimate around 120 to 150 miles on a single charge. And as I mentioned, 40 miles in the morning, 40 miles in the afternoon.
And is that typical for
That's the average.
That's
the average. Now, you've
route?
got, so we run about 46,000 routes a day in our fleet. We've done an analysis, and 75% of those routes can be covered by existing technology that we have today.
Yeah.
There are, though, rural routes. We have kids, you know, in rural areas that in the morning they're 100, 120, 150 miles riding into school, and then that in the afternoon. So those, you know, that's going to take a little bit of time before we get in there. So that's typically, we'll see it now. What impacts the range? Cold weather, of course, is going to impact the range that we will get out of it. Topography is going to impact range to some extent as well. And then, of course, hotter weather, really hot, but not as much as cold weather.
Yeah.
So we have learned our lessons. We've been operating, we operate 450 electric school buses today across North America. Our oldest unit's close to 4 years old now. We've been operating in Quebec. That's where we started our electrification journey, was in Quebec. It's routinely minus 20 degrees.
Right.
So we've learned how cold weather really impacts operational characteristics.
Yeah.
And so we design based on that. So what you have to do when you're looking to deploy electric school buses, you don't look for your average low temperature.
Yeah.
You look for your coldest day.
Right.
Because kids are going to go to school.
Yes.
And so that's what we have to start basing off of from there.
And you probably work with International and the others, Thomas, Bluebird, feedback this data.
Yeah, we
to,
give
to
them
dial this in.
Yeah, we're buying from all the manufacturers, and they want us to be operating their buses. Because we give them feedback, what we're seeing, what we're learning, what changes. So one of the things we've had to do on some of our longer routes is we've had to go with a fuel-fired heater on the buses in order to make range. So normally I would say you can tell this is an electric school bus because there's no tailpipe. Well, when we put a fuel-fired heater on it, there will be a tailpipe to exhaust the heating element. So that's one thing we've had to work with them on in order to keep the range that we want out, is put in a fossil fuel heater in order to keep the bus warm. Because by law we have to keep the bus at a certain temperature for the kids in there. And so that's some of the feedback we've gotten and give them to them as well.
So how about on that flip side with the air conditioning? Anything special you do to the bus to meet?
Just like in residential and commercial construction, you know, HVAC is a huge deal. Same on these things. And so as we go electric, that is one of the biggest things we're having to overcome, is how we heat and cool these buses. And so the industry's working diligently to come up with better solutions for heating and cooling the buses. We want to be emissions free, right? So we want to move away from those fossil fuel heaters as fast as we can. So yeah, the industry's working on heat pumps. They are developing heat pumps for school buses that can heat and cool the bus all electric much more efficiently. And we'll start testing those pretty soon as well.
All right, so more. The rest, in your booth here, we see the Westinghouse shipping container. Tell us a little bit about this, because you provide the whole solution for a school district.
Yeah, so
Tell us a little
charging,
more.
this is people believe this is the big, beautiful bus and that's what it's about. Well, that's what you see.
Yeah.
This is what you don't see. And this is actually what makes us work, is you've got to be able to charge the buses cost effectively. Not only do you have to charge them cost effectively, you have to install it cost effectively.
Yeah.
And
safely.
And
right?
safely.
That I like this setup here.
Yeah. And so this was, as we always say, necessity is
Mother of invention.
innovation. And so what we learned as we began to do school bus deployments, particularly in Quebec, the ground was frozen.
Yeah.
And to get it unfrozen cost a lot of money.
Yeah.
And so our engineering team came up with this above ground solution. So what you see here is these jersey barriers, K-rails, depending on what you want to call them, we drop these on our location. And then behind it, and we don't have it set up here today, is where the conduit runs out of our power cube. And we call this system First Charge. So that allows us to run all the power, all the telecommunications above ground behind the jersey barriers. So that reduces costs because you're not trenching, you're not pouring concrete.
Yeah.
It also creates flexibility. So if we need to move this system, you can come up with a forklift, pick it up, move it to the next thing. If you need to expand it, you just keep running the jersey barriers down the process.
So the container comes with it. That's part of the system.
With it.
Yeah.
The charging station then comes with it as well. You affix this to the top of the jersey barrier where you're going to park the buses. Comes with a cable management system so that drivers fuel the buses themselves, and we have some pretty small people, so we had to make a system that they could manage to pull the cables over and charge and do that, and comes with operation. So this is what keeps us above ground, keeps us flexible. If we have a problem, easy to unattach and put the charging station back in. If we need to redo power behind it, we don't have to dig it up and do it that way.
I really like this because I think that's an impediment to adoption is the infrastructure to charge them.
The other thing is a lot of school buses operate on leased property.
Yeah.
So if you lose your lease,
yeah,
are you going to enrich the landlord?
Right.
No, you pick this up. You take it with you to your next location, drop it right back down.
Yeah.
And so that's not only a challenge in the school bus industry, that's any medium and heavy duty operator is often on leased property, and not sinking stuff into the ground becomes really, really critical.
Yeah.
And we're also designing this system so that it's floatable. So most parking lots for medium and heavy duty fleets are in the worst neighborhoods. And why are they in the worst neighborhoods? Because they're in floodplains. So what you'll be able to do, this unit doesn't have it, but we have an option that comes with a hand crank. So if you know a flood is coming and you're going to drive your vehicles away because you know the water's rising, you sit here and crank, and you can take this unit up 10 feet up into the air and keep it out of the water. This part of it then comes on floats, basically just like a dock on a lake, and this will rise up as the water comes up too.
Yeah.
We do the exact same thing with the power electronics as well. There'll be 4 balusters, here, that go up with a hook. Flotation under this, as the water rises up, it brings it up away from the water as well.
Yeah.
This is a very expensive system. It does not like water.
Right.
And so we think it's the end.
Sorry. The odds are they can't move it quickly out of the way.
Yep.
What's plan B?
Just float it up.
Yeah.
And so, again, that comes from operational experience.
Yeah.
And that's what's so critical, and what First Student brings to the table is we're an operator. Like I said, we got to run 2.7 million kids to school every day.
Yeah.
So we have seen the challenges that come with that, and we've designed the system. As I always say, this is a system designed by operators for operators.
Yeah.
Which is critical.
Yeah.
So then the brains behind it is all of our power electronics are based within what we call the powerhouse or power cube. We haven't come up with a full name for it. This is assembled with our partners at Westinghouse outside of Austin, Texas. It's a 9001 certified facility. So everything is built to automotive grade standards within their warehouses and assembly areas in Round Rock, Texas. That also allows us to kind of do a pre-commissioning. So once everything's up and running, we actually send the charging stations down to Round Rock, set up the system inside the warehouse, power it all up, make sure it's all working together and communicating. That solves a significant number of problems that you have once you get out into the field.
Yeah.
Because you've already tested it. Once everything's assembled in Round Rock and shipped to the locations, we're usually 6 to 8 weeks to being up and running.
Operational.
Yeah. Which makes a big difference. And we can step inside if you want to. I'll see if this door's unlocked.
Behind the scenes.
So, and again, if we can bring in our chief engineer if you want to, but the power, from the utility side comes in through here, your primary panel that you have here and here as the power comes in, and then some telecommunications tied into it here. And then here is where we house all of our switchgear, all of the main panels and switchboards that run the system. And so this is why we're able, to build this in a very enclosed environment,
environmentally
protected, send it out to the location ready to go. The other good benefit that brings the partnership does is supply chain. Major issue for anybody in the electrification area now. With our partnership with Westinghouse, we've got a good handle on supply chain issue for all of the components of electrification. So if you're ready to go, we're ready to go.
And now this would support, we only see one charge station, but this could be...
Yep, so the way, typically with school buses, now this can be used for any medium and heavy duty fleet operator.
Yeah.
But for school buses, typically what we look to do is between 25 and 30 kilowatts per bus on the charging side. This particular setup can do up to 48 school buses. Now, if you go with a larger charging system, if you go to 60, well, that's going to drop you down to 24.
Yeah.
That we can do off. But the beauty of this system is once we get beyond its capacity, 48, we just drop another container exactly like this on top of this one.
Yeah.
Run the Jersey barriers the other side, stack it out, and you can do 48 more.
Modular.
Yeah, very, very
easily
modular.
Expandable.
Yeah. The other thing we've done with this is if energy supply, energy cost are really problematic, we can put a container on top of this that has batteries, nothing but batteries in it. And so we have a stationary storage component as well that plugs directly into this system, so we can better manage people's utility bills and also provide a degree of resiliency within the system as well. What we think we'll be doing with school buses is as that bus out there reaches its end of useful life on the batteries, probably somewhere between 8 and 12 years, we're not sure, we'll take the batteries out, put them in a container right above here, and give them a second life, helping us on our resiliency energy management side as well. So this is future-proof. That's the thing again, designing this for not only what you're going to do today, but what you may be doing down the road. And I like to call it a Lego block system.
Yeah.
You just click on another block on top, you click more Jersey barriers out the side, and you just keep going.
Yeah.
And then if you got to move it, you pick it up, load it on the flatbed trucks, move it to the next place.
Yeah, easy to say yes for a school district.
Yeah. And it comes with fire suppression, fire control in it as well, all the safety features you would go. Of course, ventilation for heating. This is what working with our team comes up about, is thinking through all the issues you would need to be able to address at a location.
Yeah, it's impressive.
Well, we're very happy with it. We call it First Charge. We are deploying it at our locations, pretty standard as we do that. We have other customers that are now starting to purchase it for their operations as well. And we think it's going to be a really good solution, particularly as people are trying to figure out what they need to do, how they need to do it at a cost-effective way, and then be able to grow.
Yeah, because the vehicle's the easy part of the decision, I would think. Now the whole rest of to support that vehicle.
Right, because you have to have the charging system match your operational needs. So, when we get into more southern environments where it's warmer, we can probably put in level 2 charging. You don't need the heavier DC fast charging. And so this system's kind of designed to do that as well, that you can bring in level 2 charging if you want to do that. We look at, also the issues that you have to deal with. Now we think, You know, when you think about school buses, you go, oh yeah, they run in the morning, they run in the afternoon. Well, no, they don't.
Yeah.
We have issues we have to deal with throughout the day, and you've got to be able to make sure they can meet those requirements that come up from early dismissal. If schools have to go out early, field trips you need to run. So we need to make sure we're designing the charging system to meet the needs of what those buses are going to do at that school district.
Yeah.
Please let this be a normal field trip with a friend? No way!
What's next for First Student?
Well,
This is impressive as it is, and I'm glad to hear it, right? As a parent of kids and you know, and a taxpayer,
Yeah,
right?
yeah.
But what's next for you
what's
guys?
next is growth. You know, as I said, we operate 450 electrics today in our fleet. We've got about 1,200 more on order that are coming into our system over the next year, and we just need to keep growing and growing. We have a commitment to electrify 30,000 school buses by the year 2035. And that's our growth to get there. And to get there is developing charging infrastructure that's cost effective.
Yeah.
I think the thing that's going to help us all, if it's everybody can take advantage of a low cost solution we're offering here, that helps us all, because then you can buy more buses, and that's what's going to drive down the price.
Right. Drive the price of entry.
Exactly.
Cost.
Yep.
Yes.
Yep.
All right. Well, I think Munro fans, we got a great download from Kevin. Appreciate you taking the time
Thank you for
today.
your time. Yeah.
Have a good show, and we'll be back to see. And we want to catch up with your technical person. What's his name?
Alex Cook. He's our chief engineer. This was his brainchild.
Yeah.
So yeah, get some time with him, and he will give you a mind-numbing level of detail if you want.
Yes.
But he's
So
terrific. He's a brilliant, brilliant guy. I sleep at night because of Alex.
Yeah. All right. Well, thank you again.
Thank you.
And see you next time, Munro fans.